Section 6.1, Part 2, finding equations of exponential functions. In previous examples, we were given an exponential function, which we then evaluated for a given input. Sometimes we are given information about an exponential function without knowing the function explicitly. We must use the information to first write the form of the function, then determine the constant a and b, and evaluate the function. Here is an example. Find a formula for an exponential function that passes through the given points 0 and 2 and 3 and 750. We're going to use the function f of x equals a times b to the x power, or y equals a times b to the x power, and then the point 0 and 6. If we plug 0 and 6 into the function, we will get 6 equals a times b to the 0 power. We know that b to the 0 power is equal to 1, so we get a equals to 6. Now we're going to use the next point. So if you use the point 3 and 750, you get, and you plug it into the function, you get 750 equals 6, because we found a to be 6, times b to the third power. Now we're going to solve for b, so the first step is to divide both sides by 6. If you divide by 6, you get b cubed is equal to 125. Now you're going to take the cube root for both sides, and that will give you b is equal to 5. So now we have a is equal to 6 and b is equal to 5, which means our equation is going to be f of x equals 6 times 5 to the x power. That is if one of the given points is the y-intercept. It's going to be easy to solve. What if we were given 2 points and none of them is the y-intercept? How are we going to solve that? So to find the formula for the exponential function that passes through the points -2 and 6 and 2 and 1, we can assume the function has the general form y equals a times b to the x power, just like the previous one. And then we are going to find a and b. First, we're going to plug the points. First, let's plug the point -2 and 6. So if we use the -2 and 6 and plug it into this function, we're going to end up with 6 equals to a times b to the -2 power. So from this equation, we can convert that into 6 equals to 8 times, or a over b to the second power. So that is our first equation. If we plug the second point, 2 and 1, we will get 1 equals to a times b to the second power. So we can solve, let's say this is equation number 1 and this is equation number 2. From equation number 1, we can solve for a, multiply both sides by b squared. These will cancel, and we will have a equals to 6 times b squared. I'm going to name this number 3. I will take equation number 3 and plug it into number 2. So I will have 1 equals to, I will remove a, replace it with 6b squared times b squared. So now I have 1 equals to 6 times b to the 4th power. I'm going to solve for b by dividing by 6 first. So I'll get b to the 4th power is equal to 1/6. And that will lead to, if I take the 4th root for both sides, I will get b equals to 1 over the 4th root of 6. So now I have a and b. I solved for b. I'm going to solve for a. A is equal to 6 times b squared, which means a equals to 6 times 1 over the 4th root of 6, all squared, the square root of 6. So I will have a equals to 6 times 1 over the square root of 6. And if you multiply, you'll get a equals to 6 times square root of 6 over 6. These will cancel, so a is equal to square root of 6 if you rationalize this. So now I have a is equal to square root of 6 and b is equal to 1 over the 4th root of 6. So let me just make sure that I have the right points. 6, yes. So f of x, or y equals to the square root of 6 times 1 over the 4th root of 6 raised to the x power. And that is the equation of the exponential function that passes through those 2 points. One of the applications for exponential functions is the compound interest formula. We can calculate the compound interest using the compound interest formula, which is an exponential function of the variables, the t, which is the time, p is the principal, the interest rate is r, and the number of compounding periods in a year is n. And the function is given by, and the formula is given by a equals to p times 1 plus r over n raised to the nt power. Let's use this formula in order to solve the next question. If we invest $3,000, so the principal amount here is $3,000, in an investment account paying 3% interest rate, so R is equal to 3%, or in other words, it's 0.03, compounded quarterly, so N is equal to quarterly means 4 times a year, so N is 4. So if you compound this monthly, N is going to be 12. If you compound it weekly, it's going to be, N will be 52. If you compound it yearly, N is going to be 1. If you compound it quarterly, N is going to be 4. And if you compound it daily, N is going to be 365. How much will the account be worth in 10 years? So T is the time, which is in this case in years, 10 years. We're going to apply the formula. So we have A equals P times 1 plus R over N raised to the NT power, and that will leave us with A equals to, the principal is 3,000 times 1 plus 0.03 over 4, all raised to the NT power, which is 10 times 4, T times N or N times T. And then if you find the formula, so you go into work according to PEMDAS, first you're going to find the division, you're going to add the 1 to the division, and then you're going to raise it to 40, and then eventually you're going to multiply with the 3,000. So if you do that, you will get, so after I did the math, the answer was $4,045.05. So that is the answer. Please verify the answer on your own, and if you get a different answer, please let me know.